Okay, so our next rule is the quotient rule. Okay, the quotient rule is like dividing. So the rules for the quotient rule are we're going to divide the coefficients, or technically simplify them. And then what the exponents, we're actually going to subtract them. So I first want to explain where this rule comes from. So I do teach this a little differently than some, but it might be a little simpler. It's up to you. When I apply the quotient rule, okay, so like here's an example right here. I have x to the fifth over x squared. I tell my kids, circle the higher power, okay, so 5 is bigger or higher. So, and then I subtract 5 minus 2 is 3. Now, how I know where my x to the third ends up is the location of that higher power. So it's actually going to be x to the third in the numerator, okay? When it's this way, so I have x to the third over x to the fourth, I'm actually going to have the 4 is the higher power, 4 minus 3 is 1, so that means I'm actually going to end up with x to the 1 on the bottom and 1 on top, and I'll explain that a little later. But let me explain where the quotient rule comes from, because I'm one of those that likes to know why it works and why it works the way that it does. Okay, if I take this first example right here, x to the fifth over x squared. X to the fifth is x times x times x times x times x. And x squared is x times x. So if I look at what they have in common, I can cancel these two and these two. So I'm left with three x's, which is x to the third. And that's where the rule comes from. It's the same idea when I have this problem. X to the third is x times x times x, and then x to the fourth is x times x times x times x. So these three cancel, and I'm left with the x in the denominator. So that's where the idea comes from. So we're going to take that same principle, and we're going to apply to the quotient rule. So if I look at number 1, I have x to the fifth over x to the third. It's almost the same as the example. I'm going to circle the higher power. So the higher power of the x is the 5. And then just subtract. 5 minus 3 is 2. And I know it's going to end up in the numerator because it's where the bigger power was. Then number 2, 8 and 3. So 8 is the bigger power. 8 minus 3 is 5. So k to the fifth. Number 3. So at first you look at, and we haven't learned this rule, so this is kind of a little segue to what we're going to see in the next couple of days. But technically the quotient rule says I subtract. And this one doesn't actually have a higher power. So 3 minus 3 ends up being 0. But my answer is not actually 0. M to the 0 power is actually 1. Okay? And if you technically look at it, think of this as a simple division problem. 5 divided by 5 is 1. 10 divided by 10 is 1. 100 divided by 100 is 1. So m to the third divided by n to the third is 1. So, and we'll go over the 0 power later, but just think whenever you have a variable with the same exponent, it just simplifies to 1, okay? So if I look at number 4, okay, I have two variables. I have a and b. Let's first take care of the a. I have a to the 6 over a squared, so 6 is the higher power. 6 minus 2 is 4, so it's a to the fourth. B, in 4 and 3, 4 is the higher power. 4 minus 3 is 1, so b to the 1, or just b. And there's your answer. And they would both end up on the numerator, so that's why I don't have anything in the denominator. Okay, number 5, when I introduce exponents, okay, or coefficients, sorry. So 6 over 2, think of it like division. 6 over 2 is 3, okay? So 6 divided by 2 is 3. And then x is 4 is the higher power. 4 minus 3 is 1, so x to the 1. Number 6, okay, 14 over 7 is 2. Okay, we don't subtract the coefficients. Let me be very clear. We don't subtract the coefficients, we simplify the coefficients by division, okay? So you don't subtract them. We only subtract the exponents. So on x, remember if a variable is by itself, it has a 1 as its exponent. So this is x squared over x to the 1. 2 minus 1 is 1, so this is x. 2 minus 1 is 1, so this is y. Okay? Number 7, negative 36 over 4 simplifies to negative 9. Okay, and it does stay on the numerator because 36 was bigger. Now, I see a squared over a squared. A squared divided by a squared is 1, like we talked about. But 1 times negative 9 is just negative 9, so we don't write it. Think of it, it's kind of like canceling, but we don't want to technically think of it like canceling. It actually simplifies to 1, and 1 times negative 9 is just negative 9. Then 5 minus 3 is 2, so b squared. Number 8, negative 15 over negative 3 is positive 5. Okay. So I'm going to do my variables. So this is 6 minus 5 is 1. So this is x to the 1. Y, 5 minus 3 is 2. So y squared. Now z, the only z left is the one in the numerator. So I'm just going to leave it in the numerator. There's your answer. Number 9, 4 over 8. Okay, so 4 over 8 simplifies to 1/2. Okay. Which is technically correct because 8 divided by 4 is 2, and 2 ends up in the denominator, so technically the same thing. But it simplifies to 1/2. Then I have 5 minus 1 is 4 into the 4th, but it's going to be in the numerator with the 1 because 5 was bigger. Number 10, 36 over 54 simplifies to 4 over 6. Nope, keep going. 2 over 3. Okay. Then I subtract my exponents. 9 minus 3 is 6, so this is x to the 6th. And then 5 minus 2 is 3, so this is y to the 3rd. Both on top with the numerator. All right. So now we're going to combine the quotient rule with all of the rules we have learned so far. So you ready? Take a deep breath and here we go. So the rule of exponents says that we need to take care of the power rule first, okay? And then after the so I know it's like, Miss, we learned it in a different order. You take care of the power rule first, if there's any. Then you take care of either the quotient rule or the product rule, kind of whichever one. I mean, technically quotient, well, technically it just comes with whichever one comes first in the problem, and we'll see some examples. And then we take care of any adding and subtracting. So let's go over this one. Number 11. So I see the power rule and I see the quotient rule. Okay, so first thing we're going to take care of is the power rule. The power rule says I'm going to distribute the exponent to outside to all the exponents inside. So remember, this is 3 to the first power. So 1 times 2 is 2, so 3 squared. And then 5 times 2 is 10, so x to the 10th. And then since the power rule wasn't in the denominator, I'm going to bring it down. So it's 27x third. Now I do want to clean this up because I don't want to leave it 3 squared. 3 squared is 9, so it ends up being 9x to the 10th, 27x to the 3rd. Now I have my quotient rule. So my quotient rule says I'm going to simplify my coefficients. So 9 over 27 simplifies to 1 over 3. And then I'm going to subtract my exponent. So 10 minus 3 is 7, so x to the 7th. Okay. Number 12, I see the power rule and I see the quotient rule again. So we're going to do the power rule first. That means distributing the 3 to the exponents inside. 1 times 3 is 3, so this is 2 to the 3rd. 2 times 3 is 6, so this is a to the 6th. 4 times 3 is 12, so this is b to the 12th. Since the power rule was not in the denominator, we're going to bring that down. So 4a to the 3rd, b to the 7th. This 2 cubed, and I'm just going to simply erase. 2 times 2 times 2 is 8. Okay, so you want to simplify that. Now it's the quotient rule. A over 4 simplifies to 2. 6 minus 3 is 3, a to the 3rd. And 12 minus 7 is b to the 5th. And there's your final answer. Okay. Number 13, I see the quotient rule and I see the power rule this time in the denominator. So since the power rule is not in the numerator, I'm just going to bring that one down. Now I have my power rule in the denominator, so I'm going to distribute the 2. 2 times 1 is 2, so this is 4 squared. 1 times 2 is 2, so x squared. And 1 times 2 is 2, so y squared. I do want to clean up this 4 squared, so it's going to be 4 squared is actually 16. Okay. Now I'm going to simplify. 12 over 16 is 3 over 4. My x's, 9 minus 2 is 7, so this is x to the 7th. And 4 minus 2 is 2, so this is y squared. Okay, number 14. I see the power rule in the numerator, I see the power rule in the denominator, and then I see the quotient rule. So this is three different rules. So let's first take care of the top. I'm going to distribute the 4. So 2, remember 2 is raised to the first power, x is raised to the first power. So 1 times 4 is 4, so this is 2 to the 4th. 1 times 4 is 4, so this is x to the 4th. 4 times 4 is 16, so that's y to the 16th. In the denominator, I have the power rule as well, so we're going to go ahead and knock it out. I'm going to distribute the 2. So 1 times 2 is 2, so this is 2 squared. 2 times 2 is 4, so this is x to the 4th. And 3 times 2 is 6, so this is y to the 6th. I do want to clean these coefficients up, so I don't want to leave them 2 to the 4th and 2 squared. So 2 to the 4th is 2 times 2 times 2 times 2, so 4 times 2 is 8, times 2 is 16. Nope, 32. No. 2 times 2 is 4, times 2, 8, yeah, 16. And then 2 squared is 4. All right, now I have my quotient rule. So 16 over 4 simplifies to 4. Now if you look at x to the 4th over x to the 4th, technically simplifies to 1, but 1 times 4 is 4, so it kind of goes away. So it's just 4. And then 16 minus 6 is 10, so y to the 10th. Okay, so if we continue, let's look at number 15. Number 15 looks like a doozy, but it's a big power rule and the quotient rule. So if you look at this, they want me to distribute this 2 to the exponents inside, not only in the numerator, but also the denominator. When you see this big set of parentheses, that means every single thing inside of here. So let's take it one step at a time. So remember, this 12 is raised to the first power, this 15 is raised to the first power, and this x is raised to the first power. So 1 times 2 is 2, so this is 12 squared. 5 times 2 is 10, so this is x to the 10th. That's just the numerator. And then 15, 1 times 2 is 2, so 15 squared. And then 1 times 2 is 2, so that's x squared. Now, I want to clean this up a little. So 12 times 12 is 144, x to the 10th. And then 15 times 15, oh, I don't want to be wrong, 25. 175 x squared. Nope, that's wrong. That's 225. This is where it might be helpful to use a calculator. Okay, so then I have the quotient rule. So quotient rule says I'm going to simplify 144. I'm going to go ahead and keep using my calculator here. Over 225 is 16 over 25. Now I have x to the 10th, x squared, so 10 minus 2 is 8, so this is x to the 8th. Number 16 is the same principle, so I just have a power rule, a big old power rule, and the quotient rule. So I'm going to distribute this 2 to everything inside the parentheses. Just remember that 4 has a power of 1, a has a power of 1, 5 has a power of 1, a has a power of 1, and b has a power of 1. So 1 times 2 is 2, so that's 4 squared. 1 times 2 is 2, so that's a squared. 2 times 2 is 4, so that's b to the 4th. That's just the numerator. 1 times 2 is 2, so that's 5 squared. 1 times 2 is 2, so that's a squared. 1 times 2 is 2, so that's b squared. Then I want to simplify. I don't want to leave it 4 squared and 5 squared. So this is 16a squared b to the 4th. And then 25a squared b squared. Now, since I don't believe 16 over 25 simplifies, so it's just going to say 16 over 25. And that happens. A squared over a squared is technically simplifies to 1, but 1 times 16 is just 16, and 1 times 25 is just 25. So those technically go away. B to the 4th, b squared, 4 minus 2 is 2, so b squared on the numerator. All right, so let's step up our game here. This is introducing 3 or more rules of exponents. So let's look at number 17. Okay, I see the product rule and I see the quotient rule. Well, I got over ahead myself. There's only 2 rules here. So I cannot, so this is one of those times where you have to figure out, okay, which order do I go in? I'm technically going to take care of the product rule before the quotient rule, okay? Because the product rule is in the numerator, and I have to clean up the numerator before I can simplify the quotient rule. So let's take care of the numerator first by the product rule. 9, so we multiply our coefficients. 9 times 4 is 36. And then I add my exponents. 5 plus 1 is 6, so x to the 6. 6 plus 1 is 7, so y to the 7th. Since the product rule was not in the denominator, I'm just going to bring it down. Okay, so now I have quotient rule. So 36 over 6 simplifies to 6. 6 minus 2 is 4, and 7 minus 4 is 3. So there's your final answer. Number 18. All right, this one has 3. This one has the power rule, the product rule, and the quotient rule. So let's first take care of this power rule at the beginning. So I'm going to distribute this 2 to everything inside. So this has a 1, this has a 1, this has a 1. 2 times 1 is 2, so that's 10 squared. 1 times 2 is 2, so that's a squared. And 1 times 2 is 2, so that's b squared. Okay, so this was just the power rule. So I'm going to bring everything else down that didn't apply to the power rule. I do want to clean this up, so I'm not going to leave it 10 squared. I'm going to go ahead and take care of it, and it's 100. Okay, so now that I've taken care of the power rule, we have the product rule in the numerator before I can take care of the quotient rule. So let's take care of our product rule. So the numerator, 100 times 2 is 200. 2 plus 4 is 6, so that's a to the 6th. 2 plus 3 is 5, so that's b to the 5th. Since the product rule did not apply to the denominator, I'm going to bring it down. Okay. Now I have the quotient rule. So the quotient rule, simplify. 200 over 4 is 50. 6 minus 5 is 1, so a to the 1st. And 5 minus 1 is 4, so b to the 4th. There you go. 19 has the product rule in the numerator, quotient rule, and then subtraction. Okay, so let's first take care of the product rule. 8 times negative 3 is negative 24. 1 plus 4 is 5, so that's c to the 5th. And d cubed is the only one, so I'm just going to bring that down. Since the product rule wasn't in anything else, I'm going to go ahead and bring everything down that doesn't apply. Now I have to take care of the quotient rule before I can take care of that subtraction. So let's take care of the quotient rule here. Negative 24 over 6 is negative 4. 5 minus 2 is 3, so c to the 3rd. And 3 minus 1 is 2, so d squared. That's minus, so there wasn't anything in the denominator. Now that's minus 9c cubed d squared. Okay. The only way I can subtract is if they have the same last name, which they do. C cubed d squared, c cubed d squared. So read it from left to right. Negative 4 minus 9 is negative 13. And then I'm going to keep the same last name, so c cubed d squared. Last but not least, this one has the power rule in the numerator, power rule in the denominator, and then subtraction. Oh yeah, and then quotient. So I actually did that in the wrong order. Power, quotient, subtraction. So let's take care of the power rule in the numerator. Distribute this 2 to everything inside. Remember, this is a 1. 2 times 1 is 2, so this is negative 6 squared. Negative 6 squared is positive 36. 4 times 2 is 8, so x to the 8th. 6 times 2 is 12, so y to the 12th. So that's the numerator. The denominator, I'm going to distribute the 2. Negative 3 squared is 9. 3 times 2 is 6, so x to the 6th. 5 times 2 is 10, so y to the 10th. Minus 7x squared y squared, because nothing happened there. Now I have my quotient rule, so I'm going to simplify. 36 over 9 is 4. 8 minus 6 is 2, so x squared. And 12 minus 10 is 2, so y squared. Then I'm going to bring down 7x squared y squared. Now I can subtract because they have the same last name, x squared, y squared, x squared, y squared. So read it from left to right. 4 minus 7 is negative 3, x squared, y squared, okay? So the rule of thumb when you have multiple operations in one is you have to follow a certain order. So just remember this. So from what we could see, you have to take care of the power rule first, then the product rule, then the quotient rule, before you can add and subtract. Sorry for the horrible handwriting. So just keep that in mind.